Hey everybody, this is Mr. Schultz here. We're going to take a look at lesson 11.2.2. Did my experiment show results? Here's our key today. We're going to find out, or we're going to use some sample to sample variability to determine whether two results in an experiment are truly different. This is what I think is kind of the calling card of this, is comparing two different results and trying to be like, hey, is this different? Does this make sense? I shouldn't call it a calling card, though. That's a little bit too strong of a word, but just this is a really interesting application of this, that things can look really different. And then when you look at that variability, like all of a sudden it may not be that. So let's see our first. All right, here's our story problem. Problem 11-50. The female red-eyed poison dart frog visits numerous bromeliads, which are just air plants, where pools of water have collected in the leaves. In each pool, she lays a single egg that grows into a tadpole. The tadpoles feed on mosquito larvae in the pools, but local health officials have been killing the mosquito larvae, and environmentalists are concerned because they are unsure whether the tadpoles will adapt to eat another food source. So Lewis led an environmental scientist to the rainforest, and they tagged 100 female tadpoles and determined the number that grew to adult. Mosquito larvae were placed in 50 bromeliads, and the other 50 were treated so that mosquitoes could not live there. So basically, you've got your control group of 50, or you've got your control group of no mosquitoes here, and then you've got your experimental, or vice versa. So 36 of the 50 tadpoles, 72%, survived, while 29%, 58% of the non-mosquito fed tadpoles survived. The difference in the proportion that is surveyed is 0.14, so 14%. So there's a 14% difference. So just based off that, you go, well, yeah, clearly the non-mosquito ones, they are not surviving as well. But we're going to investigate that, whether that can be explained by sample to sample variability. So what that means to you is that, hey, was this 72%? Was this one sample? Was this the high end like sample? Maybe the actual number was like, I don't know, let's call it 32. That the 32 out of the 36 does. And then when you look at this, was this the low end sample? Could it have actually been that, hey, maybe 33 of these lived? Well, then actually the non-mosquito ones you'd say would have a higher rate. So we want to investigate that sample to sample variability here. So let's check that out. Okay, so our actual problem here is that you're going to set this up and use your handheld graphing calculator or the e-tool. If you want to use either of those, you absolutely can. I'm going to use Desmos just because I'm kind of getting used to this as our approach here. So in Desmos, 70% of the mosquito-fed tadpoles survive. So the numbers 1 through 72 are going to represent the surviving ones, and the numbers 73 to 100 will represent a tadpole that died. Simulate one sample of 50 mosquito-fed tadpoles. What is your portion that survive? I'll set that up and do that in a second. We're gonna do another sample. It's gonna be 58% that survives, and we're gonna do another 50 sample thing of that. What is your proportion that survived there? So let's take a look at those two things in Desmos here. All right, team. So setting that up in Desmos, here's my 72% list here, my 72% that survived list. So again, just doing those brackets and going and that, doing your random and getting your 50 samples. I did the same thing down here. You can not see it super well. And then in theory here, what I need to do is find out the number that survived, meaning that the number that 1 through 72 survived. So I go through this list and I'd be like, this one did not survive, this one did not survive, this one did not survive, and so on and so forth, then do the same thing with 50. I already did this and just took screenshots of it, so I'm just going to use this because it'll just make my life a bit easier. 'Cause I've already got them kind of pegged out, and then you don't have to watch me count stuff and potentially do bad mental math and things like that. So here's my first one that's 72% survived. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that died. And then here's my 58% with 18 that died. So my numbers there would be, because the question here is actually asking me for what portion of your samples survived. Well, if 12 out of 50 died, um, that means that 38 out of 50 survived, meaning that that's about 76%. Okay. Then same thing with my 58. So this time I had 18 that died. So that means that I've got 32 out of 50 that died, which means I have 64%. there. What's the difference between these two portions of mosquito-fed population? So here, what's the difference between these two? So mosquito-fed was this first number, so that'd be 76, and the non-mosquito, so that was that 64. So I take that difference there and I find out that I've got a 12% difference there between those two things here. So that is my difference. Okay, so jumping to part D here, we found it was 12% in part C. So part D says the difference between the proportion in random sample is likely to be higher or lower than than that 14% or even negative because of natural sample variability. What does a positive difference mean? So the positive difference means that there is more tadpoles that survived in the mosquito areas than in the non. So then a negative, whoops. So then a negative here would mean the opposite. It would mean that there would actually be more that survive with the non-mosquito. Oh my gosh, my handwriting on this thing is so terrible. Let me try this again. Non-mosquito. Okay, so a negative would mean that there's more of the non-mosquito. A positive would mean that there are more of the mosquito areas there. So let's take a look at part E here. So part E says this. If we take the repeated random samples by repeating the simulation, we can estimate the sample-to-sample variability and then the margin of error. Below are the results of 100 trials. So this is nice because they didn't actually make us do all these trials like we did on the last one. This one, they're just giving us the data. So the table shows the difference in the portions that's survived minus the non-mosquito fed. So if we just take a look at this here, so we've got some interesting numbers here. One, we've got this huge negative. So just as we talked about in the last question, this negative means that the non-mosquito population actually outlived the mosquito in this sample by 7%. And here by 5%, and then all these other ones, they're overwhelmingly positive, just because most of the time that is what's going to happen on that. So it says here, find the upper bound on the middle 90% of the portions in the margin for error. So we go, oh, okay, that shouldn't be too. Oh, wait a second. Notice this table is not in numerical order. So instead of hunting and pecking and trying to find all these things for you, I've got it loaded on the next slide. So here I went and I found all these things. So my pink data is the lower bound. So I went and I took all my 5 lowest samples because there's 100 samples here. So that I need to take off that top 5%. So I took off my pink, which was the lower. So I took off this one, this one, this one, this one. And then this was my last one. And then here's my first sample that's now at that 95% land. So in doing the margin for error here, I do need to find halfway between these two. So my margin for error on this would be 0.015. So it'd be halfway between my fifth piece into my sixth piece there. Um, and going from there. Then I'm gonna do the same thing, but with the red, and these were my final two here. So again, I'm gonna find that halfway point between those two pieces of data. Okay, and that will allow me to then find that. So now I'm gonna find my my upper and lower bounds in the middle 90% and the margin for error here. So my lower bound, I'm going to stick with it in pink here, was at negative 0.015. And then I had my upper bound, which was that 0.295. And I'm going to subtract those two things, which subtracting negatives is of course going to create a positive. So I'm actually going to end up with 31% is my range between the upper and lower bounds, meaning that my margin for error here is going to be plus or minus 15.5% there, which I think you could round that, and I think that the book actually does in the answer key, and they call it 16% there. So that is that is how you'd find that margin for error along with that upper and lower bounds there. So let's take a look at our next problem here, problem F. So we found that sample to sample variability there, and we are ready to make a prediction for the entire population here. So we know that the original thing was saying 0.14, and that we're saying that we found that margin for error to be plus or minus 16% there. So all things said here is that we have somewhere between 0.02 negative and what would that be? 30.03 positive. So you've got quite a huge range there of what it could be for those values. So what does the difference of zero mean in context of this problem? It means that if there's zero difference, then it doesn't matter if there's mosquitoes on the plant or if there's mosquitoes not on the plant. So what this means is again, just like our last one, even though overwhelmingly most of our possibilities lie right here, there is still a possibility that that our normal average there actually leads more towards we should actually be spraying the mosquitoes because it's producing more tadpoles if you're trying to produce them. So this here, are you convinced that there's a that there's a true difference? No, we're not, because it is possible in all of these outcomes here that there is no difference or that there's actually a positive impact if you spray for the mosquitoes in those parts there. So that is what our sample to sample variability is telling us there. All right, so last thing you've got the learning log. We're just going to kind of summarize some of these steps here. Hey, what am I doing to set up the simulations, and what am I doing to find out the sample variability with the margin for error there? And that should be it. Just got your review and preview to tackle from there, and that should be everything there. Let me know if you have any questions. I'd love to help out.